Well, hi, Math 8 students. It's Mr. A, and we're going to go over the notes for our new topic, which is over volume and surface area. So, you guys I know, have already done some volume and surface area before. You probably have done prisms, and you probably have talked about cylinders. We're going to include this year, we're going to do it for pyramids and cones and spheres. Those are our big three shapes in 8th grade. So we're going to start just a little bit of refresh over what you probably have already learned in 6th and 7th grade. And then we're going to take it a step farther and talk about our shapes for 8th grade. A side note before we get started here, in order to prove some of the things we're about to do, it takes some math that's too far advanced for our class. So in order to save time and ease some confusion, I'm just going to say, hey, it just takes advanced math to get to this point, so that way we don't have to go into it a lot, and then we can just really focus on what we have to do in order for the next assessment coming up. So keep that in mind. I'm not trying to excuse the math, but at the same time, I'm trying to keep our focus where it needs to be. So let's go ahead and get started. And here's the thing, another overlying thing about this before we get really into it. Number one, you will get all the formulas for volume and surface area that you need for the assessment. We'll give them to you, we'll give them to you per problem. So you'll know exactly what formula you will need because they'll be given to you. The only thing you have to be able to do is you'll only have to make sure you know what each variable represents so you can plug in numbers correctly and get the correct answers. And then secondly, unless we tell you otherwise, you should round all answers, if necessary, to 3 decimal places. And if necessary, you should use the pi button on your calculator when doing calculations, and you will definitely need your calculator for these problems, okay? So without further ado, let's go ahead and take a look at a prism here and just review ourselves with prisms. So I'll pull this up here a little bit. And I have a couple of them here. And I'm sure you're familiar with the one on the left. That's a rectangular prism. And the volume formula underneath it is, of course, length times width times height. Very familiar, common formula here. So what's interesting here about this, though, is that the formula for a triangular prism, as you can see, is 1/2 length times width times height. And if you notice, we have I shaded a face of each one of the figures. And just to refresh yourself, a face is just a lateral surface, a flat surface of a shape. And in each case, the flat surface that I highlighted was the base of the shape. And prisms actually have 2 bases. The top and the bottom could also act as a base. So we just have the one. So if you notice, the length times the width here in the rectangular prism formula, if you notice, that's actually the area of the base of the prism. And likewise over here, the area of the base would be 1/2 length times width. Okay, so since prisms can have different shapes for their base, we have to generalize that a little bit. So what happens is that we just call the area of the base its own variable. And for example, if I do the volume of any prism, we use the value capital B right here to represent the area of the base of the prism. So it doesn't matter if the area of the base is a triangle, or if the base is a square or rectangle, or even a pentagon or a hexagon. As long as we can figure out the area of that base, or if it's given to us, we can still find the volume of the prism, because then we can just plug in that number into our formula for capital B and multiply by the height. All right, so that's just a quick refresh of where we've come from. And now what we're going to do is we're going to start comparing this to the volume of a pyramid. Okay, so let me see if I have a pyramid here. I don't have a picture of one here on the notes, so that's okay. A pyramid, I'm going to draw one here real fast for us. A pyramid is similar to a prism, but its base is only one. There's only one base, I should say. I can't draw and talk at the same time. And the other sides of the pyramid which are called, of course, the other faces, all meet at a common point called the apex. And so what happens is you have, let me move that apex up there out of the way a little bit more. The more I move it out of the way, the easier it is sometimes to see each of the sides. So that looks a lot better. One of the joys of doing this live, I guess. And then there's the last one. And so you can see the pyramid there. They all meet at the same point. All the edges going up from the all the sides, we call them edges, going up from the base. Okay. What has been determined by some advanced math, so we're not going to go into it. This would have been an exercise we would have done in class. We would have figured this out. But what we figured out is that the volume of a pyramid is 1/3 the volume of a prism with the same dimensions for the base. So the volume of any pyramid is 1/3 area of the base times the height. Okay, and again, just so we know, B is the area of the base, okay, and H is the height. Of the pyramid. And you might hear my dog in the background, and I apologize for that. That's just him moving around and keeping a watch on stuff. So apologize for any barking he might do. So that's how we find the volume of a pyramid. We just take the area of the base times the height, and then what we're going to do in our calculator, we're going to take that product and divide it by 3 instead of multiplying by 1/3 and trying to get that approximation, because you can't, of course, you can't do 0.3 because that's not 1/3. So we're going to divide that product right here that I'm going to mark in green. We're going to take that product right there and divide that by 3. And I'll show you how to do that on the calculator here in just a minute with this first example. Okay? So when you get your notes, these are going to be uncovered. I forgot to uncover them before I started doing this. So we'll uncover this picture here because I was going to cover it for our class notes. So it says find the volume of a rectangular pyramid with a base of 2 meters by 6 meters and a height of 3 meters. And this is necessary engineers for 3 decimal places. So if we're going to work this problem here, we're going to start by writing the formula down. So, of course, V equals, let's go ahead and use black for this first one here. 1/3 area of the base times the height, okay? And as you can see, the area of the base is highlighted here in blue for us. So we'll have that defined for capital B. And the height is in red. So the area of the base is in blue, what I said before, and the height is red. Okay, so we can find these dimensions, and we can plug them in the formula and find the volume. Okay, so here's what we're going to do. I'm going to flip my iPad around so we have more space. There we go. And we're going to set up this formula. So we have V equals 1/3. Now I have to find the area of the base. So over here on the side, I'm going to do a little work on that. Of course, the area is, let's do it this way. Let's not say A, let's say B, okay? Let's say length times width, of course. So that's going to be 2 times 6, or 12, okay? So what I'm going to do is I'm going to put the 12 in my formula, so it's going to be 1/3 times 12, and then I'm going to put in times 3 for the height. Okay, and then I'm going to rewrite it. So it's going to be V equals 12. Oh, again, I'll put that in blue to color code it. We'll do 12 times 3. And then we're going to divide that product by 3. And that'll take care of the 1/3. So the 1/3 in this division of 3 right here, so this division of 3 to there and this 1/3 here are the same. Okay, and that way you can get a more accurate answer in your calculator when you go to multiply it. So we're going to go to the calculator right now. Let me go ahead and find it here on my iPad. It's right here. I just have this one right here ready to go. Actually, yeah, we'll use this one. So I had 12 times 3, hit equal. I got 36. We're going to divide that product by 3, and I get 12. Okay, so back to notability. And so I can now conclude the volume is 36 divided by 3, which equals 12. meters cubed. Whoops, that one didn't quite go as I thought it would. Let's try this one. There we go, much better. All right, so that's how you find the volume of a pyramid. Basically, you just got to find the area of your base, if it's not given to you already, and then multiply that number by your height and divide by 3. Okay, so I have another example here for us. This one, I want you to work on your own for a minute. So go ahead and hit the pause button now and give this one a try on your own, and then I'll help you. I'll check the answer with you here in just a minute. And we'll do this for subsequent videos and that kind of thing too, where I'll show you a problem and then you'll have a chance to work another one on your own. So hit pause and try it, and then unpause and wait for the explanation, okay? Okay, well now don't be alarmed if this is a base that has that's a pentagon, because in this case you were given the base area. So you were told, like right up here, if you notice right here it says, whoops, it tells you right there that B is 24 feet, right there, okay? 24 feet squared. So that number can go automatically in to the formula, okay? So that's exactly what we're going to do. V equals 1/3 times 24 times 8. Okay, so then I'm going to have, and we can color code these real fast if we want to. So I'm going to go ahead and color code this so it's consistent. There's that one, and we'll do this one too, so it's consistent. There you go. And then we're going to switch it so it's a division problem. That way we can get in more accurate. We can get the accurate answer. So V equals 24 times 8 divided by 3, okay? And let's go ahead to the calculator and get that answer. So, oh, there's the Decimalist calculator. I'll use that for the next video. I couldn't find that there first. So, actually, you know what? Let's just use it now, because that one just quit on me unexpectedly. Okay, and I'm going to split the screen. So we'll put Notability over here on this side. There we go. So you can see the notes go here at the same time. And I'll reverse back to this orientation here. There we go. All right, so we'll do 24 times 8. Okay, that's 192. So go ahead and write that down. All right, and divide that by 3. So we'll take that, oops, hit enter, and then hit the answer button, and divide that by 3, and that gives us 64. So the final volume for this pyramid is 64 feet cubed. Now, if you get a problem in your homework assignment that doesn't divide evenly by 3, then just round your answer to 3 decimal places. Okay, so 3 places after the decimal point. All right, so we'll use this new setup here to work on the rest of our notes. All right, and I'm going to stop this video here with pyramids so you can do the first assignment. And I'm going to do the next video on cones, and probably spheres too, because they won't take that long to explain. Okay? So good luck, and again, email me if you have any questions. Take care.